Alright, what you have here is an exercise in creative thinking concerning the solar interior. These are the solar granules that are on the surface, and this is where the majority of the chemical reactions occur. Right here. This is a young star, like the sun. Young star. Now if you notice, the granulation is very thin. And mind you, this is maybe, what, like 10,000, 20,000 kilometers or something like that? Perhaps possibly more. These are very big cells, convective cells right here. The granulation. But what happens is these granular bubbles, they get bigger. Very, very large, very thin granular bubbles provide the sun its internal structure. But these are very vacuumous, and as you move towards the center, it gets more and more vacuumous. As well, the majority of the heat from the surface, okay, is on the surface. And these convective bubbles protect any extra incoming heat from going towards the center. So what you have here is a cold interior. This is where the sun is right now. Establishment science wants you to believe that there's a nuclear burning ball in here and it just radiates outwards. But that doesn't make any sense, because what you have is sunspots. Okay? Now the surface is 58, 80 Kelvin, right? But when they measure the sunspot temperature, it's like 3,000 Kelvin. Why on Earth would a hot interior, okay, moving outwards, be cooler? See, it should be getting hotter. This shouldn't be 3,000 Kelvin. If you go towards the center of the sun, it should be getting hotter according to the fusion model. But it doesn't. It gets colder. We know this because sunspots. And these sunspots are part of some type of convective cells. And then as the bubbles reach out further, it gets cooler. So say that's 3,000. Then you have maybe 1,000. Okay? And as you move towards the center, you eventually get to be around the temperature of outer space. 2.3 Kelvin. Maybe a little bit colder. I'm not too sure. But anyways, this is the structure, what I think is, of young stars like the sun. And the reason why I adopt this structure is because I like the idea of it being hollow for the most part, as well having a thin interior structure full of these bubbles that are, well, comprising the interior of the sun. But not many chemical reactions are occurring here. I mean, the most violent ones are obviously at the surface. Exothermic reactions. I'll go over that in another video, which release heat. But when those reactions happen, chemical reactions, mind you, they drop down because they're heavy. And they start raining down through these convective walls and depositing towards the center. And as this material moves towards the center, the shell contracts. So there will be contracting. Lots and lots of contracting. And the star will begin cooling and moving towards the orange dwarf stage. Because this is the sun right now as it is. It's going to cool and it's going to move towards the orange dwarf stage. And the interior is going to move up a little bit in heat, as well as this is going to move up in heat. And this is going to cool down. So the heat on the outside moves towards the center. Hopefully this helps my viewers. If they have any comments, please leave them at the bottom. But I assure you, this doesn't exist anywhere on the internet. I guarantee you that.